So C++ template is an approach to write a more efficient code. When we have to write same type of code or a little variation of the same type of code, we use three approaches. Okay, so the approaches for functions that implement the identical tasks for different data types. So we use the naive approach, we use function overloading, and we use function template. So we already know what is function overloading, and you have practiced naive approach before, and today we will see how we can apply function template. Now let me explain with an example, it will make more sense. So what is actually an identical task? So for example, look at this program. You want to write a program that will print an integer, that can print a character, or that can print a float. That means or that can print a double. That means your program can print integer, it can print double, float, all data types. So normally before you learned function overloading, what was the approach? Approach was to write different function for each case. So for integer, you would have written print integer. For character, you would have written print character with this car data type integer. For float, you will also write the same way. So previously, this is called the naive approach, that you would have written same different function for the same type of task. Okay, now what is the problem with the naive approach? First of all, you have to write a lot of functions, and not only that, okay, it is difficult to keep track of multiple function names. So this is a problem with the naive approach, and it leads to programming errors. Sometimes you make a lot of mistakes whenever you're using the naive approach. So what is a naive approach? Again, we create unique functions with unique names for each combination of data types. So here we are creating unique functions: void print int, void print car, void print float, void print double. So we are printing all those for different data types. And what is the problem? It is difficult to keep track, and it leads to a lot of programming errors. So this is our first approach. Second approach is function overloading. So what we do in the function overloading, we start with this approach. So we write the same function, so void print, void print, void print, but we use different signature. That means we use integer here, we use character here, and we use float here. In this way, what happens, even though all the functions name are same, just when we pass integer, this first function gets executed. When we pass a character, this function gets executed. When we pass a float, this print function gets executed. So this approach solves the first problem. What was the first problem? The first problem was it was difficult to keep track of multiple function names. But now you don't have to keep track of multiple function name. Now, next problem, that in this one, what it does, it reduces the changes of unexpected results. So in this case, you don't have to do so many changes. Okay, just one change is enough. So it solve the problems of naive approach. So far we have already learned function overloading and how it works. We have seen some examples as well, right? Now, still there are some problems with function overloading, and then those problems are get solved by template. Now let us first see what is a template with an example. So in the case of template, if we just go for the same approach, okay, where is it? Sorry, yeah, this is the example. So first we write the same function, void print. Okay, then instead of writing integer or float or character, what we write some type. So this is a variable, and then we write the val. So if I go back to the previous example, just for a quick recap, if you look here, in this one, the name of the function is same, print function, print function, print function. But in this one, it is integer n, and depending on that, it's character ch, it's float x. So we have one, two, three different functions, number one, and each of them have three different data type. Now, what we're doing, we are combining all this, okay? So if I go back to here, So instead of writing 3 different print function, we write one print function, void print. And instead of writing integer or float or character, what we do, we write some type, and then we just write the variable name, and rest of the part is same. Now the question is that if I write here some type, how should the compiler understand whether it's an integer or it's a float or it's a character? And that is gets solved by the template class. So what does this template class does? It creates a holder or common data type that can actually first take input and check, okay, this is an integer, so let's apply the program for the integer. I will show you one more example. This is a character. Let's apply the program for the character. So let me show you an example now. Before going to the example, let us see the book. Okay. So here we have this integer function with integer argument. We have character function with the character argument, and we have float function with the float argument. So what we did, we replaced this integer. Okay, we replace this character, we replace this float with a common argument. The name of the argument is t. Okay, so t is a called template, and then again we replace this one, we replaced this one, and we replaced this one, and also we replaced it with t. So our new function name is, all of them is replaced by t. So t function, and the data type is also replaced by t. So in this way, what we did, we have created a common data type, and that common data type is called template. And before creating the template class, we have to declare the template class t. Now instead of t, if you write here other variable name or other type holder name, that works as well. Now let us see the code. So this is the first code we have for a simple function. So let us see the code before. So before we had 3 different functions. What this function does, it returns the absolute value. What is the absolute value? That if you give -5, it will return 5. Okay, if you give 5, it will return 5. That means just the main value. We used this type of operations in our math course called mod operation. So this is a function that applies the mod operation, returns the value, ignores the sign. So previously there were 3 different functions: integer apps for integer, in long apps for long, and float apps absolute for float. Now what we do, okay, we write only one function, okay, t apps tn. So t is the template, apps is the function name absolute, and tn, n is the variable. Now let's go to the program, main program. So first thing, we have to include template class t, so that this is defined as a function template. Otherwise this t will be unrecognized. When we write this template class t, it will understand that, okay, this is a template class where this function can be implemented for multiple cases. Now we start with main program. So we write integer 1 equals to 5, integer 2 equals to -6, and we declare 6 variables, integer, long, double. Now what we do, whenever we call this function, okay, we just call abs, short for absolute, and then we call the integer 1. This programs, okay, automatically comes here. It doesn't matter it's an integer or character or float or double. Okay, it checks the values, it operates on the same line of code, and then it returns the value. So output will be 5, 6, 7, 8. That means it works. If we go back to our slide where we were seeing the code, so this is also does the same. We just define the parameters, and then in the template argument we pass the values. So let us see some definition now, that what it actually is. So in C++ language, construct that allows, template is a construct that allows the compiler to generate multiple versions of a function by allowing parameterized data types. That means instead of using parameters, we are actually parameterizing the data types. Previously, whenever I declared an integer, I could store 5, I could store 6, I could store 100 in that data type, right? So because that was a variable that could handle any integer. Same way, in this case, this is a template class, is a way to make the data type as a variable. So you can store, you can operate any type of data types. Now this is the basic definition of a function template, template parameter list, and this is called a placeholder. Now let's see another example. So when the compiler instantiate a template, it substitute the template argument for the template parameter. So the example here is that, as we have seen, we have three approaches: naive approach, function overloading, okay, and finally the template functions. So in the naive approach, we have to use different function definitions. That means print integer, print character, and all of them have a different function name. In case of function overloading, the function name can be same, but the definition of function have to be different. Like the signature of the function have to be different. And in case of template, one function can do the task for all of them. You just have to parameterize the data type. Now, there are many other examples. Let me show you one more. So in this one, let me go to the book. I think book will cover easier examples. So here we have another one. Now, this is a shortcut. You will not need this right now, but you will need it in your next course. That is whenever you are using a data structure. So using this templates, what you can do, okay, using this class templates, okay, you can actually implement class as well. Let's assume you don't know whether your class needs integer or float, okay. So what you can do, you can declare a class as a template as well. Now, let's assume we have a class called stack, even though we didn't still study stack, but this is the main idea. So in this one, we are creating a stack where you can store integer numbers, okay? And then you can do some basic operations of stack. Now, suddenly your programmer have asked you that, okay, instead of using integer, I want to use long. Or let's think about a student class. Okay, in the student class, you want to store student's name as a string. Suddenly, another one of your friend, he want to store as a character array, or maybe just a number. Okay, so the data type suddenly might change. So in this one, we have integer and we have long. So instead of creating two separate stack, okay, for this class, what you can do, you can create a template class. And in this template class, instead of writing integer, you see here, we are writing integer stack. Here we're writing long stack, okay. But instead of doing integer long, what you can do, you can write type stack. So what will happen if you write this type stack, it will automatically handle integer, it will handle characters, it will handle other data types. So you don't have to worry about that. What you can do, you can just focus on the implementation. So in this program, as you can see, whenever we declare a float stack, it only works for float. If you want to use a long state, it only works for long. But if we use a template class, it will work for all types of data. Now that's the basic idea. Let me show you another example where we use a linked list. Linked list, you will also learn linked list in your data structure course. But whenever you are implementing a linked list, this is a code that will help you in a long way. So whenever you are learning linked list, you will see that initially the linked lists are taught as a integer for integers. That means for numbers, and then you will be given a task that, okay, the linked list is an integer, now apply it for characters or string or so on. Okay, so you have to write a different program, so you have to change a lot of part of the program. But if you use a template class, you have to write one program, and doesn't matter whether the teacher gives you an integer or the teacher gives you a character or float. Okay, your program will work for all the data types. So this is what this template class provides you with. So you will write one single code or one single class or one single function, but your code will work for all different types of data. Now, you might ask, sir, what is the advantage of this? But because this seems a little bit different, or for some of you, this might also seems a little bit difficult as well. To in short, to give you the understanding of the advantage, just look at this too. So this was the code that we used with function overloading. You have to write three different classes, okay? But if you use the template, you just have to write one function. Now think about a scenario where you have 20 types of data or 100 types of data. Okay, so that means if you don't use the template class, you have to write, even if you use the function overloading, the updated and the most advanced things you have learned in the C++ course, still you have to write 100 different functions. Okay, but in case of a template, you just have to write one function. So this is one advantage that is just there. Okay, then there are some other scenario, like in function overloading. If you give the integer first and the float second, and if you just swap them, they are two different signature, because we know whenever we're giving the signature of function, it depends on the order of the parameters, the type of the parameters, and so on. But in this case, it doesn't also matter, because if you just write some type, it will handle integer, it will handle float, and so on. So just to summarize this, okay, what is a template? Template is a C++ construct or a mechanism that helps you to write efficient code. Okay, and in this way, all the data types are parameterized into one single function. And it is better than the naive approach, that is this one, that you write different functions for all the cases. It is better than the function overloading. That's it. There are two examples that I have shown. You can go through them, and there are also details into the book. Let me go to the book again. So there's an example for linked list. You can see this code is huge, almost like 100 lines. Okay, so if you use template, this stays 100 line. But if you don't use template, what happens? This you have to write two codes, that is 100 into 2, 200. Just think about a code of 1000 line. If you use template, it stays 1000 line. But if you don't use template, it becomes 1000 into 2, 2000 lines. Okay, then comes last one. Where is it? So sometimes we use EML, UML, unified this language to store represent the templates. So you can do that. Okay, but if it's up to you, because you will learn UML in our whenever you're doing the software engineering course. So for now, you can ignore this as well. So in our next class, we'll see exceptions, and I will give you one little example in your next assignment about the templates, so you can actually run the code and see how it works.